So here we are, first job today. We've got that Mercedes Sprinter, but we're not working on the van, we're working on the trailer. The guy's, apparently he's either got no brake light on one side on the trailer or no tail light on one side. We'll find out. I'm pretty sure it reported on the worksheet that it was, the way we're looking at it from behind, it's the near side rear that's not working. So we're going to run through a couple of tests on it. Hopefully it's something simple. So where the guys are working over there, this is a, I don't know how you pronounce it, maybe Battison trailer. Quite a nice body. So turn on the side the tail lights, and you can see the tail lights are working on both sides, and the number plate lamps. But it says this has been an intermittent fault. So they've already removed some of the screws. They've just left it loose for me because they were trying a new bulb in it. So we will take the cover off first of all. And you can see in there a tail light is working. Well, it doesn't really take much to notice the issue here. So if you look closely, you see the two legs, or the two blobs of solder. You can see it's, I bet you if I give this a done, not so much, maybe try and, you can see there that it's literally just touching the leg of the bulb there. So maybe if I give this a little, there we go, look at that. So you imagine going over a bump, that goes off, goes back on. So I don't really know what's happened there, to be honest with you, but I'm going to take that bulb holder off and straighten it up. It should be fine after that. That was an easy one. So the reason this has happened is because if you look at that blue wire there, that blue wire is a brake light feed. So you can see how tight that is. So what's happened is that, with that being so tight, it's moved that over and made it lose contact with the tail light side. Don't know why that's happened, maybe that was just like that from factory, or maybe, I don't think anybody's been in here, to be honest with you. Because the trailer looks pretty tidy. So while I've got this off, I'm going to give that a clean with a grinder. You can see it's not really got the best contact on it with the rust there. So we're just going to run across that with the grinder quickly. Well, I've ran an extension in, same colour of wire, so it's got the professional sort of look. We'll wrap that up with a wee bit of tape as well, so that won't tug on that pin for the actual bulb. See, that will give that one a clean up as well. So what I'm going to do is just a bit too much, but that is what it is. We're going to fit a new bulb as well. I'll just stick a wee bit of grease on that. And there we go. So I didn't film the rest of that, but it was just a case of putting the lamp back on. That's the job done. Trailer lights and that are working. No further issues. So yeah, that's it. So we're at this Fiat Toblo. The actual garage is round the corner, so this is parked out the way, which to be honest, I'm not too bothered about. I've had to just park the van there, put the beacons on, because there's literally no space to work for me to park the van. So the issue with this is both low beam headlamps are meant to be not working. So what we'll do is, if I can find the key, so if we turn our ignition on, put our headlights on, you can see you've got nothing. Absolutely hee-haw. So I'm going to struggle with this one a wee bit because we've not got any diagrams for this. I cannot get a hold of any, but we'll run through the basic tests anyway. So we took a wee bit longer in this one. So in here you've only got your high beam relay that's in here, so we're not interested in anything going on in here. So just a wee quick simple check that I'm going to do, that I'm going to show you. I can deal with that later. Is I've got the two bulbs sitting out, so I want to check your wiring integrity. So in here, your two fuses up the top, the two 7.5, well sorry, the one 7.5 amp fuse is the headlamp fuse for both headlights. So what I'm going to do is I'm going to run power to that, and hopefully you'll be able to see. Well, I'll set these up actually. So as you can see, the headlight did come on. So the problem is not the wiring to the bulbs. The problem is in fact in the BCM itself. So guys, to cut a long story short, I've done a bypass on this because the BCM isn't available according to the garage, because they've already tried to get a hold of one. So I've just done it onto a rocker switch here, so on an ignition feed through a relay, through a diode, so it's safe. I didn't show the installation side of it, but listen, we're here to get things back on the road. It's coming up to Christmas now. Like I says, trying to get a second hand one, he was trying to get one, he couldn't get one with the exact numbers, so this will do. It'll pass MOT. That's basically all we need it for. So guys, this is the next one. It's getting a wee bit late now, so I'm not going to completely record everything on this. We've got a Porsche Cayenne 2007, I believe. Is it 2007? We don't know, it's a private regi, but it's an older Porsche Cayenne anyway. We're checking this for a battery drain. I don't know if this is a thing that's happening overnight. I don't think it will be, because it's only drawn right now through 340 milliamps. That's still a lot, but we've only let it settle for about 15 minutes at the most. So we'll let this settle down and then see where we go for there. I don't even know if this is interesting, but I'm just recording it anyway. That wee Fiat Doblo over there. Obviously round about here you're kind of stuck for space. The garage is in there, so I'm getting cars brung round to me, which I'm not too bothered about, because the forecourt at that garage is tiny, so I don't blame them. So here we are with this Transit. It was a crank no start, now it's a no start. Starter, everything, all that sort of side of thing, it is fine. The garage thinks it's maybe a network fault or so, but we've had network faults on these before, so this might be pretty straightforward on where to look. So yeah, let's get on with it. So this is a Transit, so we've got a typical CAN fault. So what I've done is I've marked right there. So if we give that a hit, you'll see the dash light up. Usually, I can get it to do it. So what I'll do is I'll give it a hit. Right, so let's give it a... And as per usual, it's hard to catch on film. It's alright, that's fine. Aye, so it's in there. You can see it better with the camera. See that wireless speed chaffing? See the wee bit of copper through it?
How's it there?
Aye, so what that's doing, that's rubbing on that chassis.
Is it just that one wire? Is there a few?
Just,
blue one that's like it's built.
it just looks like mainly that network wire that's away.
Are you able to access that?
I should be fine to repair it. Let's try and get a better.
So you don't use Legos like
No. So you can see we've got it running. That's us sorted. I didn't film much of it because the customer's in the back of the van. But you can see pretty common fault with these anyway. But we'll move on to the next one. All we done there was just we taped it up and put a bit of padding in between it so it can't cut itself through. All good. So it's a different day, different job. We're at a Citroen Picasso 60. Oh, I want to say a 64 plate. Might be a bit newer than that, maybe a 67, I'm not sure. But this one's experiencing blows running all the time, even when you switch a car off. So unlike the Peugeot partners and the other ones before them, the heater blowers are controlled through the BSM. This one's got its own sort of module, sort of in with the resistor. So we're going to diagnose it for him. So this is a car, so you can see the blown motors are running all the time. Even when you try and adjust it, they're still stuck on. So yep, so that's basically the fault confirmed. You can see up here, and there is where a blower module, resistor slash module lives. See up there, you can see the two wires at the bottom actually come out the resistor and go directly onto the motor rather than the power wire going into the fuse box or coming out of the fuse box in the BSM. So I'm hoping you can hear me over these blows. What I'm going to try and do is divert them to the feet. Yep, so you might be able to hear me a bit better, but I'll talk anyway. So what's happening here is we have got our oscilloscope. Now you don't need to do this, the actual blower resistor module is faulty, but we're going to do this anyway just as a sort of extra bit in the video to actually show you what's happening. So if obviously we're in a fault state tonight because the blowers are stuck on, but we're going to turn the fan up one notch. And you can see there, that's the waveform, that's the signal that's coming from the actual controller on the display. So that's the signal there, and you can see we've got a duty cycle of 76%, 77%. So if we keep increasing that, you can see the duty cycle will slowly go down in its percentage all the way down. So when we're full, we're meant to be on full speed just now. The duty cycle is 15%. Don't know how accurate that is, but whatever. But you can see here, if I take away the control, you can see the duty cycle increases, and then that's us off. So we're going to get one priced up. It's a Denso part, and we'll inform the customer of the repair cost, but this right now is just a diagnosis. So I move on to the next one. So this is our next job. We're at a Mitsubishi. We have got a whole lot of faults on this. We've also got the likes of the AS and G system, FCM, temporarily unavailable, but as per usual on these sort of cars, it happens on a lot of other cars as well. Once something comes on the engine management side, it starts to create a sort of ripple effect in all the control modules and start reporting things that may or may not be true. So basically on this we've got a couple of received and validated, sort of similar sort of fault codes and those sort of words, and different wording I should say. So this is what we've got. I'm going to clear because I've been unplugging things. I've already diagnosed this. So we're going to read fault code. So you can see we've got no fault code. If we start the car up, So the car is started up, you can see all the warning lights here, the engine management lights back on. What is that? You can see the car starts to intermittently rev itself. Anybody know what that is? I've never seen that before. Anyway, so we'll go on to read fault code. You can see it's just started raining there, I know, it's just typical. So we've got a P0238 turbocharger / supercharger boost sensor A circuit high, and we've also got the same fault code P0238. So we've got, that's the two fault codes that we've got. Then we've got two boost pressure sensors on this car. So we'll go on to, I've had to get into EOBD for this because it didn't show you on the Mitsubishi side on this machine. So we'll type in boost, and we'll go to boost pressure sensor A and boost pressure sensor B. Now if we click on them, you can see the boost pressure sensor B reacts, no problem. You go to boost pressure sensor A, and you can see there we're stuck at a default value of 338 kPa. Two sensors on this car, you can see there I've marked them. That one's sensor B, and the one just before there, that's sensor A. So this is what the sensor looks like if anybody's interested. It's just got a little tiny hole right through there, and I've already put pressure sensor B onto this one here, so I'm going to put the faulty or suspect faulty component onto the other side and see if the fault code switches. Off the phone there to Mitsubishi, for one of these sensors it's £284. That is crazy for a boost pressure sensor. That is how much that is. So if you plug the faulty one into the opposite side of the loom, you can see there it's just rising willy-nilly. So unplug that, it goes back to a default value as said before. We plug it into the location where it's meant to be, and you can see it dips down and then just rises wherever it feels like, and that does not change. So I'm at one of my trade customers here. We've got an A-class with tail lamp issues, side light at the offside rear, intermittently working. So if you have a look here, you can see that the actual collar snapped to hold the bulb into place, so you can see the bulb is dim. If I squeeze, what the collar's meant to be doing is holding the pins closer. If I squeeze it, it's kind of hard to tell on camera. If I move that collar back, so I'm not really filming much today because I'm feeling a bit under the weather, but you can see here, hopefully I can get it on camera, but you see how that's went dimmer there, back again. That's all due to this collar being snapped. Now the customer did try and replace this bulb himself, so we're going to put it on the scope and see what's happening, because once it does go open circuit, the network goes back to 12 volts. So I'll show you what that looks like on the scope. So you can see there we're in a fault state now. We're back probed into the feed going into the actual bulb itself, and that's what the waveform looks like. We've got a up to 8 volts peak. The computer's just looking for that bulb to turn on, so if I give this a flicker, see that's our bulb back on, and that is what a waveform looks like. I couldn't really get a clearer sort of image. I don't know why that's on there. So yeah, so that's basically what that looks like once it's working okay. You can see it went back to being faulty again. And that's our waveform. So what I'll do is I'll just touch a bulb. You'll see it come back to life. That's a good waveform for that bulb. Or for the circuitry for that bulb, coming out of the actual body module.